Okay, welcome everybody. Today we are going to talk about mole mass calculations, mass mole calculations, and mass calculations. And as you can see by just saying them, they are very similar um, in what you have to do. The actual moles to mass conversion or mass to moles conversion, you've already done that both in chapter 3 with just elements by using the mass from the periodic table, and in chapter 7. There we introduced compounds and you did mole problems there. So the same rules apply and the same guidelines apply, that for every 1 mole of a substance, there's a certain mass in grams from the periodic table. For example, in 1 mole of water, there's 18.02 grams, and that just comes from 2 hydrogens and 1 oxygen. The 2 hydrogens being 1.01, combined 2.02, and then oxygen being 16. So these conversions are no different than what you've done. The one step that you learned last class, this moles of A to moles of B, that's your mole ratio that comes from the balanced equation. In stoichiometry, regardless of what type it is, you'll always have that conversion. That's the simplest type of conversion, the mole-mole conversion. But we're just going to add some things to it. Everything we're going to add to it, you've already done. Okay? So let's take a look at these mole to mass conversions. So most of the time in chemistry, the amounts are given in grams instead of moles. However, if you have to convert moles to grams, if you're given a mole amount, then this is what you will be doing, some mole to mass stoichiometry. So this would be where you're given moles of one substance and you're asked for grams of another substance. So this first example, this really isn't in your notes, just kind of for you to follow along. So here's the balanced equation. Remember, all stoichiometry starts with a balanced equation. You have to have that. If you don't have a balanced equation, you don't know the mole ratios and you can't do the problem. Okay, so here's our balanced equation, the formation of sodium chloride from sodium and chlorine, so 2Na plus Cl2 yields 2NaCl. Okay, so here's the setup that I want you to take a look at, and then we'll cancel these out and I'll kind of show you where everything came from. So we have moles to start. Okay, so when you have moles to start, you can go right into a mole ratio part of your calculation. Okay, so that's where you go from one substance to the next. So if we take out our pen here, that's where we're going from here to here. Okay, for every 2 moles of Na, you have 1 mole of CO2. So by doing that, you change the substance. And that really is what the mole ratio step is for. You change from one substance to the other. Okay, so therefore the moles of Na cancel. You want that on the bottom, so it cancels here. Now, you're asked for grams of chlorine. If this would have been what you did last class, and you were asked for moles of chlorine, you would stop. You would do 5.00 divided by 2, and you get 2.50 moles. The only thing we're adding to that is, like I said, something you've already done, is just converting those moles to grams using the molar mass from the periodic table. So in 1 mole of Cl2, that's made up of 2 Cls. So when you go to look up Cl on your periodic table, that's 35.45. You multiply it by 2, and you have 70.90. So your moles of Cl2 cancel. And then you just have to do the math. 5 divided by 2 times 70.9. And you get around 177 grams of Cl2. Okay, so let's just real quick take a look at that. Mole ratio, first step, then converting it to grams from the periodic table. So that's where this number came from, the 70.90. 2 Cls from the periodic table. Okay, so let's try one here. I have 2 examples. I think one will suffice. I did give the answer here for the second example, but based off of this balanced equation is 132 grams of CO2. If you'd like to try that one on your own, you'd like to pause the video and maybe try that, you can. That's up to you. But I'm going to do one example for each type. Okay, the example we'll look at, and then the one we'll actually do. So this first one here, what is the mass in grams of glucose? So if you're not sure what glucose is, which you may not be, it has to be somewhere in this balanced equation. If you look at these four substances, it's pretty easy to pick out what glucose is. That's this right here, the C6H12O6. You have CO2 here, that's carbon dioxide, there's water, and there's oxygen gas. So we know what we want grams of this. And sometimes I'll write like G above that just to know this is what I need, grams of C6H12O6. Is produced when 3 moles of water react with an excess of carbon dioxide. So I have 3 moles, 3.00, oops, I didn't get a point there, 3.00 moles of that. And I have to convert it to grams of that. So I'm going to start with what I'm given, 3.00 moles of CO2, or H2O, I'm sorry, H2O, okay. And so I have moles as my unit. So I'm going to go straight to my mole ratio step for every 6 moles of H2O. So 6 right there. Okay, and you'd say mole, H2O. Sorry, it's getting messy. I'm going to slide it in there. There we go. So that says 6 moles of H2O. You have 1 mole of glucose. So 1 mole. So that's the mole ratio, 1 to 6. C6H12O6. There you go. You can use your imagination. So now moles of water cancel. So if we needed moles of glucose, we would be done. But we don't. We need grams of glucose, so we have to go one step further. So we just add on like that. And then in 1 mole of glucose, I'm going to save you the laughter, so I'm just going to leave it there. 1 mole of glucose is a certain number of grams, so 6 C's. Okay, so I get out my calculator. 6 times 12.01 plus 12 times 1.01 plus 6 times 16. And you get 180.72. 180.72 grams of glucose. Now you just have to do the math. Don't forget that 6 down there. 3 divided by 6 times 180.72. And that's 90.36. We'll round that up. 90.4 grams. Okay, and that's your final answer. So your mole ratio step was first. We had to cancel our mole of glucose with mole of glucose. And I got this mass right from the periodic table. 6 C's, 12 H's, and 6 O's. Okay, now moving on. We're going to speed it up a little bit because this is relatively the same thing, except for your mole ratio comes second and your conversion to mass comes first. So this mass to mole calculations, you'll be given mass of one substance and asked for moles of a different substance. So the first thing you have to do is convert moles or mass to moles, grams to moles, by using the mass of the periodic table of this substance, whatever that happens to be. And then this is your mole ratio. So this is periodic table. This is mole ratio. Okay. So it says here we can also start with mass and convert to moles of product or another reactant. We use molar mass and the mole ratio to get to moles of the compound of interest. So again, this is one that isn't in your note packet. You can just kind of follow along. Calculate the number of moles of ethane needed to produce 10 grams of water. So here's the balanced equation. You wouldn't have to come up with that. It's just a combustion equation of ethane plus oxygen equals carbon dioxide and water. Okay. And here's my setup. So I have 10.0 grams of water. I have to convert that first to moles. I can't do a mole ratio step and I have grams as a unit. So this 18.02 came from the periodic table. That cancels there, and 1 mole of H2O. Now, this right here, for every 2 moles of C2H6, you have 6 moles of water. That is our balanced equation from your mole ratio from the balanced equation. Okay, so it's 2 to 6. So now you just have to do the math. 10 divided by 18.02 times 2 divided by 6. And you get there behind my face 1.85 moles of C2H6. 0.185 moles, excuse me, of C2H6. Okay? All right, moving along. Here's one that we'll do on our own. It says 8 grams of SO2. So this is what I have right there. I have 8 grams of that. Okay. and it reacts with an excess of carbon. That just means you have plenty of that carbon. How many moles of carbon monoxide are formed? So this is what I need right there, question mark mole. Okay, how many moles of this do I have? All right, so let's start with our 8 grams of SO2. SO2. Okay, now we can't go straight to the mole ratio step. We have to get to moles first. So 1S is 32.07 plus 32, 64.07. So that goes on the bottom, 64.07 grams in 1 mole of SO2. Remember, regardless of what the balanced equation says, when you're doing a gram to mole conversion, it's always equal to 1 mole. Okay? And then now we go for every 2 moles of SO2. That comes from the balanced equation. 2 mole of SO2. There is 4 moles of CO. So 4 mole CO. Okay, so mole SO2 cancels. Your gram amount cancels. Now we just have to do the math. So 8 divided by 64.07 times 4 divided by 2. And you get like 0.250. So we have 0.250 mole of CO. Okay, 0.250. So 8 divided by 64 times 4 divided by 2. So we had to go first from grams and then to moles. So you can probably see where this is going. And these mass calculations we're going to end up with today are really what you do. You usually start with mass and end with mass. So the downside is there's 2 molar mass calculations that you have to do, because one substance you have to change from moles to grams, and the other substance you have to change from grams to moles. So it does take a little bit longer. Okay, so here's those mass calculations. Mass of A to moles of A, so this will be from the periodic table of whatever A is, the gram amount. Then here's your mole ratio from the balanced equation, and then changing it back to grams of a new substance. So it's going to be a different mass than this substance here, but that's just changing it back. Okay. And it says here, most often we're given a starting mass and want to find the mass the product will get. Okay, now we must go from grams to moles, mole ratio, then back to grams of the compound we're interested in finding. Okay, so calculate how many grams of ammonia are produced when you react 2 grams of nitrogen with an excess of hydrogen. So here's that balanced equation. N2 plus 3H2 yields 2NH3. So we're going from 2 grams of this, okay, how many grams of ammonia, to grams of this. So it's gram to gram, mass to mass. So it's going to be 3 steps. So here's your setup. So let's go through each one. We start with the 2 grams of N2 that we're given. That's right here. Even though in the question it just says nitrogen, remember you pick it out from the balanced equation, which is N2. Okay. From the periodic table, nitrogen's 14.01. You have 2 of them, 28.02 and 1 mole of N2. Okay. Now here comes your mole ratio. For every 2 moles of NH3, 1 mole of N2. So that's changing your substance. And now we have to go back to grams of our new substance, which is NH3. 1N, which is 14.01, and 3 H's, which is 3.03 combined. So when you go 2 divided by 28 times 2 times 17.04, you get 2.43 grams of NH3. So you go 2 moles, you do a mole ratio step, and then you go back to grams of the new substance. So like I said, there's 2 molar mass calculations here, which sometimes can lengthen the time of the problem. Okay, so here's the one we're going to do here, and it lengthens how much I have to write out here as well. So here's our balanced equation. Sn plus 2HF yields SnF2 plus H2. Okay, how many grams of SnF2 are produced? So this is what we're trying to find. We want grams of this. From the reaction of 30 grams of this, HF, so we have 30 of that grams, with an excess of 10. So that just means that we have plenty of 10. So I need to go just in words from 30 grams of HF to moles of HF using the periodic table. Then from moles of HF to moles of SNF2 by using the balanced equation. The mole ratio is 2 and 1. 2 HFs for every 1 SNF2. This will actually be set up of 1 to 2 of this to that. And then finally go back to grams of SNF2 using the mass from the periodic table. Okay, so let's start way over here. 30 grams of HF. Okay. Oh no. There we go. 30 grams of HF. All right. So HF needs to go down here on the bottom. F is 19.0 and H is 1.01, so it's 20.01 grams of HF in 1 mole of HF. You'd think I'd get better at this. Okay, so now we have, my grams will cancel there, grams cancel. Now we have moles of HF. So for every 2 moles of HF, I think when I do it quicker and bigger, it works better, but then I guess that's true. HF, you're probably sick of me clicking and looking down at the screen. Anyway, so 2 moles of HF to 1 mole of SNF2. So 1 mole of SNF2. Okay, so that cancels. So now we have moles of SNF2, but we're asked for grams. So we have one more step in 1 mole of SNF2. There's a certain number of grams. And that's going to be SN 118.71 plus 2 times 19 or 38. 156.71. 156.71 grams. That cancels. That cancels. Now we just have to do the math. 30.0 divided by 20.01 divided by 2. Don't forget this 2 hanging out right down there. Times 156.71. And that gives me 117 grams of SNF2. 117. Okay. Any questions on those? So you have 4 of these to do. The homework is only on mass because it really is the most important one. But I want to build up to that. Okay, so you have 4 mass calculations to do. So please do those. Check your answers with the provided answer key, then mark the assessment that you did complete it. We really only have, after today, we're going to do some mixed stoichiometry the next class, and then we have a review, and then we just have our last exam, which is just a few problems for you to work on. Okay, so we're almost done. We're getting there. Keep working hard and keep up the good work.